Hello everyone, and welcome to the Western Governors Association webinar on species distribution modeling and scenario planning. This webinar is part of the Western Governors Association Biosecurity and Invasive Species Initiative. I'm Bill Whitaker. I'm a policy advisor for forest, rangeland, and invasive species management. We will get the webinar underway shortly, but first I'm going to hand it off to Kevin Moss at WJ. He's going to go over some of the logistics for today's event.
Great, thanks Bill. Hi everyone, and thanks for joining today's webinar. We're going to have opening presentations from all of our panelists today, and then we're going to transition to a moderated discussion and then Q&A with the audience. At any point, feel free to send in questions, and the way that you can do that is either with the questions tab at the top center part of the webinar platform, or you can use the chat box on the left, and you can just send a private message to me, and I'll get it over to Jeff, our moderator. So thanks for listening, and I hope that everyone sends in lots of questions. Thank you.
Thank you, Kevin. And so this is Bill Whitaker again. I'm, as I mentioned, I'm a policy advisor, and I'm the project lead on Governor Ige's Biosecurity Invasive Species Initiative. And for those of you who have joined us throughout the initiative, welcome back. But for those of you who this is your first webinar, thank you for joining us. A little background quickly on the initiative and what we're aiming to achieve. This initiative was launched in July of 2018. It is the signature chair initiative of Hawaii Governor David Ige. Every WJ chair, as they're incoming, has the opportunity to select a single issue that they can focus a large amount of the association's resources, attention to, and policy work to. And as the incoming governor, David Ige, selected the biosecurity invasive species, not only because it is a very important issue to Hawaii. They struggle with invasive species management. It's been called the invasive species capital of the world, and because it impacts the resources, but it's sort of a microcosm of what's happening in the West as well, and these large-scale, landscape-level impacts and threats posed by invasive species. So Governor Ige was looking to host lead a year-long conversation on looking at both biosecurity, the work that's being done to prevent new species from moving into an area, either into a country, into a state, into a management unit, and also invasive species management, the work that's being done to control, eradicate, and respond to new and emerging species. It's a really wide-ranging topic and touches on a lot of issues and a lot of resources. So to accomplish this conversation, the Western Governors Association has hosted a series of workshops across the West last year. The first one began in September in Nevada. It was hosted by Nevada Governor Brian Sandoval. That was followed by a workshop in Wyoming hosted by Wyoming Governor Matt Mead, followed by Governor Steve Bullock hosted a workshop in Hawaii, and then finally in December, Governor Ige hosted the final workshop in Hawaii. And then all of those workshops focused on different themes ranging from early detection and rapid response to management of established species to collaboration to agriculture. There's a lot of really good conversation. For those of you who weren't in attendance or who weren't able to watch those, we do a really good job of live streaming all of our events. So I'd encourage you to go to westgov.org under our website, under the initiatives page, and check those out. Those are all up there, and they are a resource, so I'd encourage you to go back and refer to those. And so out of that conversation, we realized that there were some topics that we did not touch on or that needed further exploration, and that's what the webinar series is for. And that's why we're having these webinars today, is to get a deeper dive into specific policy issues or technical tools or things that just needed addressing coming out of the initiative. And so that has been, over the last 3 months, we've had a series of 4 webinars, this being the 4th, on topics including the impacts of invasive species on fisheries, conservation districts, and invasive species management. We had one last week exploring the state-federal relationship, the one today, obviously, and this is the first time we mentioned this, but next week we are going to be releasing a pre-recorded webinar on innovative approaches to addressing forest health and invasive species in the Pacific Islands. It's a really interesting conversation with state forest or from Pacific Island foresters and representatives from the U.S. Forest Service talking about the unique challenges of invasive species and forestry management in Island. Had to record that one due to the time change challenges, but check out WGA's website under the webinar page on the initiative page on westgov.org and check that out. And then today's webinar is going to be on, as I said, addressing an issue that has gotten some discussion, but we felt needed more discussion throughout the initiative, and that is just to look at what technical tools and modeling tools and decision-making tools are out there. There's a lot of science, there's a lot of good work that's being done on this issue. It's constantly evolving, and we really, using technology, using research, using the tools that are available to help understand what where the species are, where the invasive species can go, where the ranges, where there's some habitat suitability, where the species can't go. All of those things really help land managers and invasive species managers understand the risk more and give them a snapshot of what they're up against. And in a field like invasive species, where there's practically an infinite number of species, and there's more every day coming in, but there's a limited number of dollars and staff to deal with that. Using good science, using really sound, rational techniques to try to understand where things are going and the risks that you're facing are vitally important to spread those thin dollars even further. So that's what we're looking to highlight today, the good work being done by both state and federal agencies to help develop and implement those tools. So all of this work, including these webinars, are going to be posted on our website. I encourage you to go look at those, and everything that we've learned through the workshops and the webinars too are helping to contribute to a report that the Western Governors Association is writing, which is going to be available on the WGA's. It's going to be released in June in association with our annual meeting, and is going to be on WGA's website. So I would encourage you to look for that report and check it out. There'll be the outcomes of this webinar will be there as well. So with that, I am plan to turn it over to our moderator now. So Jeff Morisette is the serves as the science coordinator role at the National Invasive Species Council Secretariat. Through his work, the NISP Secretariat looks for ways that the latest science and technologies are being used in the battle against invasive species and ways to leverage and work across federal and state agencies. Before joining the NISP Secretariat, he spent 10 years at NASA and 8 years at the USGS, where some of his work focused on the use of satellite observation and climate data to build the type of habitat models that will be highlighted today. He also worked on developing mechanisms to engage land managers in the process of both construction and using these, both constructing and using these models. And Jeff I've known Jeff for several years now. Jeff has been a very good partner on WGA in a lot of different issues. He's always been a good person to call with technical questions or issues, and he's just been very enthusiastic about the initiative, and he's just been a great resource throughout this, including today. So Jeff, we really appreciate you doing this and your role as a moderator, and I will hand it over to you from here.
Great. Thanks a lot, Bill. It's great to be asked to help with this. I think that what WGA brings to an issue is fairly well received bipartisan support across those western states, and they focus on important issues. And so with those two things, it's exciting that WGA is considering invasive species as a priority issue, and I hope the leverage and amplification of the issue is brought by WGA is going to help us move the needle and work some of these issues and make some advances in the battle against invasives. So appreciate that. When Bill and Kevin reached out to me and explained the purpose of this particular webinar, really focusing on tools for more proactive management, one of the first things that came to my mind was some of the USGS and NPS work that you'll be seeing, and then subsequently they brought in Doug's work in the state of Washington, and learning more about that, we found they're very complementary. There's some similar tools and mechanisms being used with all three of the efforts you'll hear about today. So looking forward to have that shared with the group. I do want to recognize in the role of the National Invasive Species Council Secretariat that there is a lot of other federal work being done, but a lot of that work is for a specific purpose. It's within a specific bureau, within a specific agency. But I think as that's developed, and I think what we'll see a little bit today with respect to the USGS and NPS work, even in other agencies, when that work is developed, the heavy lifting is that initial phase, and so hopefully by climbing that learning and development curve, there might be opportunities to turn the crank a little bit. So there's a lot of work being done across the federal agencies, and I have the privilege to learn and see a lot of that stuff. But I think that what we're going to hear, the purpose of this call, from what I understand, is I would ask participants to listen. It's very interesting material that will be presented, but then kind of actively watch for how these tools might roll into some useful applications for those folks that are listening in. Of course, caveated with resource or capacity constraints, but I believe everybody on the call is willing to kind of look at follow-up and see where this could be leveraged. So just an overview of what we'll be hearing today. Doug Haubrich with the Washington, he's the Noxious Weed Coordinator for Washington Department of Agriculture, is going to describe some very proactive and sort of sophisticated tools that they're doing with respect to some of the invasive species that are plaguing that state in agricultural domains. And then Catherine Jarnevich and Terri Hogan. Catherine's with the U.S. Geological Survey at the Fort Collins Science Center. Terri Hogan's the Invasive Plant Manager with the National Park Service, are going to be talking about kind of those same modeling tools, but an online system that helps present those results in a way that can really help, coupled with locations of known occurrence to evaluate risk for park NPS management units and jurisdictions. And then we're going to take the work that Brian's done with respect to then I think kind of taking a deeper look into management options and different scenarios. So kind of building on those habitat models to look at some simulations involved with quantifying different management options or scenarios, and that sort of involves not quite an online tool, but facilitated discussions where that sort of deep analysis is kind of at the level where those conversations need to happen, but an example of how that unfolds. So I think with that, I will start off with Greg. Greg Haubrich, again, with the Noxious Weed Coordinator from the Washington Department of Agriculture, and I will hand it over to him and let you guys dig into the technical part that everybody is tuned in to hear about. So
all right,
over
well, thank
to
you.
Greg.
Okay. First of all, I'd like to thank Bill and Kevin and Jeff and the Western Governors Association for hosting this webinar and doing all the work they've done in the past. Also, I want to mention I have a head cold, and I'm going to try not to croak too badly through this thing. I have some water I can drink from time to time. I also want to give a shout out to Justin Bush from the Washington Invasive Species Council and Jen Parsons from the Washington Department of Ecology, who provided some of the slides that I'm going to show today. So let's just jump into this feat first, and I'll talk a little bit about MaxEnt, which is short for Maximum Entropy Modeling. It's a relatively common presence-only tool used for predicting the potential distribution of species based on a set of records and environmental predictors. And the panelists that are going to follow me use some form of this as well. And this is just one of a number of species distribution modeling tools that are out there. It's just there are a lot of different things to try. I'm not selling this or anything. It's just the one that we happen to use. And one of the reasons we selected this is it requires presence data, but it doesn't require absence data, so that's a plus for us. It's fairly easy to use. It performs well. There's a lot of papers out there that you can read, you can Google, and find that this is one of the more respected modeling tools available. Something else we liked is it was free, so we were able to use this for free. And at the time we started looking into modeling, we had a staff person that had used it before, so it was kind of a no-brainer for us. Is it perfect? No. No, it's not perfect. There are numerous papers out there that discuss its drawbacks, mostly having to do with potential effects of sample selection bias and a few other things. But there's a great quote by George E.P. Block, a British statistician, that says, essentially all models are wrong, but some are useful. So that's kind of my take on this is nothing's perfect, but it's something that we feel works well for us. Let's see. Okay. As I mentioned, you have to have presence-only data to get the model to work. So where do you get the data from? How do we collect all of this data? You need georeferenced locations of target species. So you need GPS points for the data that's collected. And Washington State is the 18th largest state in the country in terms of square miles. We have 71,000 square miles. We also have 153 species of weeds on our state noxious weed list. So given that we have 153 species of weeds in a large area and very diverse area, we have all types of habitats in Washington, we need a lot of help in collecting these data points. So one way we do that is we developed some collection tools that we provide to cooperators. We base this on an app called iForm, iForm Builder. We also have Collector from Esri, and we use those two together, or we can use them separately. And what we do, our agency provides iPhones and iPads, because this only works in the iOS world. We provide licensing and sometimes data plans. And what we really provide is technical support to folks that may not have any other form of technical support. We also work with the cooperators to help them get collector licenses and AGOL licenses, so they can continue to progress and work on their mapping at their level. And when I say at their level, mostly who we work with are county noxious weed control boards. We have 39 counties in Washington, and 38 of those counties have activated noxious weed control boards. And nearly 2/3 of those county weed programs are cooperators and use our data collection apps and software. In return, again, we provide them sometimes with hardware, sometimes with software, whatever they need, and mostly with technical support. So some of the counties are very not well funded. They have maybe a part-time staff person or a single staff person and very little access to any kind of GIS support, so we provide that to them. The entire pest program that I work in, and we deal with weeds, insect pests, pathogens, snails. We use iForm exclusively to collect all of our data. We also provide viewers to the county programs and our cooperators so that they can look at all the data in their county, and also a map widget that allows them to print out nice-looking maps for their county commissioners or their weed board, and support them in that way as well. That's not the only source of data, of course. We get data from a lot of other places. So some of the county weed programs that aren't direct cooperators with us also have their own data collection tools, and we share data with them, with other state agencies. We exchange data with, we have good partnerships with the Forest Service and the Bureau of Land Management. We exchange data with them. And we get data from tribal folks, non-government organizations, farmers, ranchers, private citizens, and a lot of that comes in via other apps. For example, the Washington Invasive Species Council has an app, and they collect sites for noxious weeds and animals. EdMaps West, Chuck Bargeron's group, provides a free way for citizens to collect data, and we share data with EdMaps on an annual basis. The Pacific Northwest Invasive Plant Council has a citizen scientist app, so we're able to get data from them as well. Herbarium records and museum specimens sometimes are useful and sometimes not, because oftentimes they're not georeferenced and we're not exactly sure where that data was collected. So anyway, back to the modeling. You have all this data that you've collected, and we have this map represents our known invasive knotweed locations, and that's all 4 species of knotweed that we currently have. And you need to have this data to be able to make the Maxent software work. Currently, we have over 21,000 knotweed records in our data set, but that's always expanding. This is just a slide of what the Maxent interface looks like. This is kind of an old slide. It's version 3.3. Version 3.4 came out in early 2017, so there's a newer version. Just I wanted you to notice that we have a knotweed entry on the left side, and then on the right side, you put in all the environmental predictors and the environmental layers that you want to use for your model. So again, this is a very oversimplified, but you have various model inputs. You can get data from WorldClim. They've got a nice set of bioclimatic variables. There's data all over out there, and it kind of depends on what you're trying to model. If you're modeling an insect species, you might want different data than if you're modeling a weed that maybe doesn't move as fast or something like that. So you kind of got to think about what kind of data you want to feed into the model. So again, the data all feeds into the Maxent software, and what is produced are some visualizations of of your data, and allows you to start looking at things and making some management decisions. This is what the model output looked like for us for knotweed. The red colors are a much higher probability of infestation or invasion than the low blue colors. So it gives you kind of a picture of which areas you're looking at. And of course with knotweed, it's generally a riparian plant, not always, but generally riparian, so a lot of the waterways show up red. And kind of a practical use for all that, once you have all that mapped or you have your model built, is you can zoom in and start looking at individual areas. And this is something we did a while back. This is we did this just to kind of show the importance of early detection and rapid response, but this is a model we did that showed just west of Mount St. Helens, where we had found small infestations. I'm sorry about the level. There's some little green dots, I don't know if you can see them, that show where we found the knotweed, and we went in and treated it at a cost of $3,400. Then we decided to look and see what would have happened if we had done nothing and let that expand to the areas that we feel that the model showed it would expand to. And if we then allowed that to happen, and that may have taken a number of years, but at that time we were looking at the control cost being $150,000 as opposed to $3,400, and that's that doesn't take into any account the factors that it's also damaging to the environment. This is just a cost analysis, which sometimes is easier to explain to the layperson than the impacts to fish and other things like that. And this is something we really want to expand on with in the future, is showing again the benefits of early detection, rapid response. Another thing we use the data for, we in Washington, as most western states, have a tiered noxious weed list. We have Class A, Class B, and Class C weeds. Class A are limited in distribution, and the goal is eradication. Class B weeds, like Scotch broom in this picture, are widespread in one part of the state but not in the other, and the idea is to not allow that expansion to occur into areas where we don't have it, and to try to use biocontrol or whatever we can to reduce the numbers and mitigate it as well as we can in areas where it's widely spread. So with this map, we're trying to, this is what the State Noxious Weed Control Board that determines the classifications for the weeds uses to do the management. And it's sometimes difficult to get cooperators or others to collect data on widespread weeds because they're simply everywhere. Why do I need to collect data? But by showing them that we can use the data for modeling and to provide management plans, that helps provide some incentive for them to go ahead and collect data. So for instance, we have a lot of Scotch broom in the state, but we only have 1,700 records in our data set. So that's kind of something we're working on trying to increase. Something else we've done with the data is we recently released this public noxious weed data viewer. So the public can go into this, and this is on our website, and look at the weeds in Washington. There's a little box in the upper right with a drop-down menu that has all 153 species in there. so they can pick the species they want to look at and see what its current known distribution is for Washington. And to protect the private landowners, as you zoom in, you get down to about a 2-mile scale, all the dots go away. So you can't really tell which weed is on whose property. But this has been something that we've had a lot of people asking us for. And we have another data set that looks similar to this that we provide to agencies that does still have all the metadata and the geo-reference positions attached. Okay, something else we've done with the data is use it for developing an economic impact of selected invasive species for Washington. And we did this back in 2016. And this was sort of a follow-up to a lot of work that's been done in Oregon. Oregon did a study in 2000, and then they updated it in 2014. And a constituent of ours in Washington saw that and said, "Why don't we have that for Washington?" And we decided they got hold of the right folks, and we decided we would do an economic impact. And unfortunately, we were right at the end of the fiscal year. We were getting toward the end of the year where we didn't have much money, and we didn't have much time. So we kind of sat down, the Invasive Species Council, the State Weed Board, and myself, the Department of Ag, and talked about how we could pull together enough support for these to be able to do this analysis. And we kind of passed the hat around, and several state agencies kicked in, and we wound up collecting about $30,000 to get this study done. And this is available on the Washington Invasive Species Council website. I'm just going to touch the top of it, but if you want to read the data behind it, you can go there and find it, or get a hold of me, and I'll be happy to send it to you. And what we did is we sat down and decided we had enough money to look at about 23 species, and unlike Oregon, we decided to add some animals to that list. So those are the species that we looked at, and quagga and zebra mussel don't occur in Washington, but we still wanted to have an idea of what the impacts might be. I'm not going to go into all the detail behind it, but you can see the distribution in Washington in 2016 played heavily into our data into doing the analyses. And we didn't have time, and we didn't have the money or the time to do modeling, and I wish we could have. So I think in the future we would like to revisit this and actually have some expansion models in place for that. So in lieu of that, we had to kind of look at what we had and talk to people and use our own expertise and collect data from other places to be able to tell how wide these species could spread and how fast they spread in Washington. And we looked at a whole lot of indicators and matrices as far as impacts considered by each species: toxicity, damage to crops, erosion and flooding, fire, all kinds of things. But again, you can read those on the website or talk to me about them later on. So what were the results? We found overall these 23 species, if we did absolutely nothing and let them expand to their potential, we would be looking at $1.3 billion in losses per year and a loss of up to 8,000 jobs. And Oregon is a larger state, but their study came out fairly similar to ours with $1.5 billion to $2.4 billion. They looked at 25 noxious weed species and up to 40,000 jobs lost. Just as an FYI, the most costly invasive species out of those came out to be rush skeleton weed and Scotch broom on the plant side, and apple maggot due to our large apple growing industry in Washington, and the aforementioned quagga zebra mussels that we don't have yet wound up being the most costly of the species that we looked at. Then we were approached by the counties that asked us to maybe look at them another way. They said, "Yeah, that's all well and good, but how does this affect my county? How can I take this to my county commissioners or decision makers and use that data?" So we revisited this with knotweed and came up with the impacts by county. King County would be the most affected, and again, you can find this on the website. And this was quite useful to a lot of our counties, and we'd like to do more of this county-level impact analysis, but we just haven't had time or funding yet. And this was actually used by Lewis County when they went for an increase in their per parcel assessment rate. They were able to look lean on this report and show that, they were looking at $6.2 million in losses if Scotch broom continued to expand in their county, and they were able to get that increase, so that was kind of nice. Lastly, the last thing I want to talk about is using the data to maybe develop region plans. This is a flowering rush. I don't know how many people are familiar with that, but it's a terrible plant. It's basically eating us alive in the Pacific Northwest. So a few years back, the Invasive Species Council and Justin Bush got a grant to form a Columbia Basin Cooperative Weed Management Area. And our first plant to focus is flowering rush. You can see it involves, the CWMA involves Montana, Idaho, Oregon, Washington, and provinces in Canada. And we're working on developing a basin-wide plan, and in order to do that, we kind of have to know what we have and where is it. So this is our first shot here at a map. This is all flowering rush data that's been collected. We house it at the Department of Agriculture, and we have also got the green data are areas that have been surveyed and where we haven't found any flowering rush. And the idea is to use the plan to seek implementation funding and, of course, to develop a potential distribution model. And this has already paid off a little bit because the Army Corps of Engineers has come up with $2 million to work on the control of flowering rush. So, again, the data and the modeling is important when you go to develop these plans. And that's really what I was going to close with. I'm about out of time anyway, so I'm going to pass this back to the moderator.
Well, thanks a lot, Greg. Despite the cold, I think it came through loud and clear, and certainly a lot of information and a lot of great work. So that's exciting to see, and I imagine other states could learn from it or at least collaborate on some of those concepts. And I think it points out at the beginning of your talk the real importance of that foundational occurrence data, and that's certainly kind of the gold with respect to these habitat models need to mine for to be useful. So next we'll go to, I think Terri is going to start off the presentation. Terri Hogan with the National Park Service. She leads the charge on their fight against invasive plants and coordinates the exotic plant management team, as well as has been active in the Federal Interagency Committee for the Management of Noxious and Invasive Weeds, or FICMANU, which rolls off the tongue, I guess. And after that, Catherine is going to talk about on the technical side, where USGS has been received some funding from USGS to work with that in-kind support from Terri to make these tools available. So, and Catherine Jarnevich has been doing species distribution modeling for longer than I have, and it predates the 2000-ish. So really an expert on habitat modeling, written papers about the caveats involved with habitat modeling, some of the issues and technical challenges, as well as the uses. So really some powerhouse as far as taking the models that Greg did explain and creating a tool that, again, maybe could be leveraged for other jurisdictions, but we'll see how it's being used in the Park Service. So with that, Terri, I'll hand it over to you.
Okay. All right. Thank you, Jeff. I'd also like to thank Bill, Kevin, and the Western Governors Association for their interest in invasive species and for facilitating these discussions and learning opportunities for all of us. So Catherine and I are going to be talking about the development of a new tool that's being created by USGS in close collaboration with the National Park Service. And the project has also benefited greatly from the additional assistance and support provided by Peter Engelstad, Nicholas Young of Colorado State University, Ian Pierce, Helen Sofair, and Julia Sullivan of USGS, and Jennifer Saraki from the National Park Service. So this work is important because it will provide a tool to assist in invasive plant management efforts. As we all know, invasive species pose a significant threat to public and private lands, including natural and cultural resources and facilities within the National Park Service. Land managers need tools to help make strategic decisions about where to focus limited resources to best address invasive plant control. So through this work, a tool is being developed to support informed decision-making and improve effective management of our resources. And the Park Service has worked in close collaboration with USGS on this project. We started with a pretty lengthy list of potential projects, and then we shared that list with the exotic plant management teams across the country to help narrow down the list to the highest priority projects. And we've also been working collectively to develop the list of species to include, and are working collaboratively on development of the online tool. So this has been an iterative process that's been informed by feedback from the National Park Service, but we are broadening our effort to gather input from the land management community through presentations like this one. Catherine, I'm going to turn it over to you.
Thanks, Terri, for the introduction of the process or project. So what I'm going to first talk about is how can species distribution models be used, and Greg provided some introduction to this, but what we've been thinking of in development of this tool and what needs it might address to the management community is thinking about regional risk assessment. So at that regional level, what species might be in a region that you might not be aware of. We also think it could be useful in helping develop watch lists. So what EDR species within my region should I be focusing on? And then it can also be useful in identifying potential habitat for a species across a large region, which, especially with invasive species, can be important because within a smaller area, you might not capture kind of the full range of environments where species might be found. They could also be useful more at a local level to target management efforts, so within a park unit or something along that scale. And it could provide information about where you might most likely find a species that you want to go out and treat, so it can help focus where you send crews to do treatment. And it could also be helpful in focusing where you should search for satellite populations. And I think a lot of research has shown that targeting these kind of satellite populations can really help control the overall invasion amount more than kind of the large patches that might be easier to find on the landscape. So I also wanted to go ahead and just provide a couple examples of species distribution modeling efforts that we've been involved with that are good kind of success stories. So here's an example of a species distribution model for gypsy moth that we developed in collaboration with people with the Forest Service and with APHIS. And APHIS is responsible for trying to keep gypsy moth from invading new areas within the U.S. where they haven't yet established. And so they've been able to use these models to target EDRR efforts to high-risk areas in the country. And so, for example, on the left-hand side, you see a zoom in to the Pacific Northwest with some blue stars, and those are populations that were detected using this model. That they were then able to go in and control that before the population really became established. And this is also a good example in that it's an operational use of these species distribution models where the agency updates these models on an annual basis with new information that was collected in the previous year, and then uses that new model to inform efforts in the next year. Another example is work that we did in partnership with Colorado State University for the Forest Service. So the picture that you see here is an area in Wyoming that burned, and the kind of reddish-brown patches you see on the hillsides there are patches of cheatgrass. And so what we did here was developed a species distribution modeling using remotely sensed imagery to map where cheatgrass might actually be on the landscape. And then the Forest Service was able to use these maps to first go to funding sources to obtain funding, and then to guide aerial herbicide application to try to control cheatgrass in this post-burn landscape. So next I'm going to talk about, for this project that we've been doing with the Park Service, the model development and delivery. And I want to mention that this project has been funded by the USGS Invasive Species Program and the USGS Core Science Systems Science Analytics and Synthesis Program. And we've also received a little bit of funding from Fish and Wildlife Service, and then we've been working closely with the Park Service for this. So the model development is similar to what Greg mentioned when he discussed Maxent. We're using aggregated location data. Most of it comes from the Biodiversity Information System, or Biodiversity Information Serving Our Nation, the BISON database, housed at USGS, and also data from EDD maps. And we use these aggregated location data along with various predictor variables that might influence where a species is found on the landscape. And we're feeding these into various model algorithms. So we are using Maxent, but we're also using 4 other algorithms to try to capture uncertainty from the algorithm that's used. And then we can use these, again, to make maps of suitability across the landscape. So the predictors that we're using, we have a national library that we've put together of around 60 different predictors that include information about climate, about topography, soil type. We also have some predictors related to anthropogenic influences that could provide information on how these species are getting dispersed across the landscape. And as we model each individual species, we're selecting a subset from those 60 possible predictors that are targeted for that species. So what we think for that particular species might be limiting its distribution. So next I'm going to talk about model delivery. This is being done through the Inhabit tool, which stands for Invasive Species Habitat Tool. And this is an online tool to deliver models to managers. And it's being developed to be compatible across device types. So you could use it on your desktop computer in your office, but if you're taking a tablet out in the field, you could also use it on that. And I'll also mention that this project is less than a year old, and so we're still really wanting to get feedback on what features would be useful and what the utility of this tool is. So we've been trying to iterate on the tools we're developing it by getting, people who might be using it on the ground to make decisions, to get input from them, and then iteratively changing the tools as we go through it. So next I'm just going to show a few screenshots of the draft tool as it currently stands. So the main screen that you get to shows is map output. So here's an example for fountain grass, showing a map for the U.S. And one thing I think I didn't mention yet is that this project is currently focused on plant species and making models for the continental U.S. So here you see the map for fountain grass, and then there's also a blue outline around the known distribution for the species and the occurrence data that we use to develop this model. So this is showing the same map, but here we've mapped out areas that have higher uncertainty because those locations have environmental characteristics that are outside the range of those that were used in the model. And so what that means is, say that all the locations were for elevations under 2,000 feet, then any location in the U.S. that has an elevation over 2,000 feet would here be maxed out, because we didn't have any data for that area and we don't want to try to make predictions there. We can also zoom in to a location. So here we've zoomed into Joshua Tree National Park. And the other thing with these models is that the output that you get originally has values ranging between 0 and 1. And so to say if a location is suitable or unsuitable, we have to choose some sort of threshold between there and saying anything above that value is suitable, anything below is unsuitable. And so instead of choosing a single threshold, what we've done here is choose several different ones that are more or less conservative. And so this is the least conservative threshold, so it's going to show the most habitat as suitable. But we allow users to select a different threshold, so here's a somewhat less conservative one, and then you could continue moving up. And so we thought this could be useful to people depending on what they want to use the model for, what type of decision they want to make. They may want to have more or less certainty of maybe of that location being suitable habitat. So say you're doing a risk assessment, you may want to have a less conservative threshold where you show more suitability. But if you're sending a field crew out somewhere to control something, you may want to have more certainty. And so you may want to have a more conservative threshold, like is shown here. So zooming back out to the national level, I want to focus your attention on the top bar there where you can choose different tabs to go through. So another tab that we have is variable response curves. So here it shows which predictors went into the model and which were most important, and then also kind of a general shape of the curve. So for this particular species, minimum temperature in the winter was the most important predictor variable, and you can see how that species responds to it. So maybe it didn't do as well as at really cold temperatures. Another source of information that we provide is on the data summary tab. And here we take, you can select a species, and then what we're showing here is national park units for that species. And so looking at the top line, we have Yellowstone National Park, and then we show the estimated suitable area within the park, the percent of the park area that is suitable. Then we have information on whether or not there were known presences for that species, and then also the minimum distance to a known occurrence. And so we're hoping that this could be useful in kind of a risk assessment for locations and maybe developing species watch lists. And another new tab that we have across the top that I don't have a picture of is a feedback tab, which is where people can provide feedback either on the models themselves, because we hope that we can iterate on these to improve them over time, as well as on the features of the tool and the utility of the tool. So we have a lot of questions that we're hoping to get information on. These include, how might you use the tool for planning and in the field? This could be for an established versus a new invader, for regional versus local assessment. We're also interested in who key partners are to involve in getting feedback on this tool. We really want to engage the land management community in the development of this to make it useful. Also, what are top priority tool features? What should be downloadable from the site, and in what format would it be most useful? There's also the opportunity to suggest future priority species to add. So we have a list of 40 species that we'll be completing this year and getting into the system that came from discussions with the exotic plant management teams and some other agencies. And then in the next year, we hope to create models for at least 50 more species. And we're also interested in what people would view this tool as being a success. And there is bit.ly link, so a short link to the tool here. We have gotten some feedback, mostly from federal people, that the link doesn't work well for them. So if it doesn't, please feel free to email me, and I can send you a more detailed link. But we're, at this point, really interested in getting feedback on this and how we can make it most useful for people who are managing invasives on the ground. Thanks.
Fantastic. It's great to see that sophisticated, high-level modeling distilled in such a what seems to be a useful way. It'll be interesting to see that feedback. And again, it's kind of a first year into the project, so a lot of work within that time frame. And thanks to Terri for providing that management need, and Catherine's solid and long-standing work on the topic. That's exciting to see. So with that, we'll hand it over to Brian Miller. He's a research ecologist for USGS. He's with the North Central Climate Adaptation Science Center and has done, as I hinted to earlier, kind of a little bit deeper dive into what else is going on in the landscape with respect to climate projections, with respect to management decisions, and how to really play that out in direct collaboration with the land managers in those regions. So not really an online tool, but taking advantage of some species distribution model tools and and simulation tools to get at some quantitative assessment of those questions. So I think it's pretty exciting work to hear about. And so with that, I'll hand it over to Brian.
Great. Thanks very much, Jeff. And also a thank you to Bill and Kevin for having me on. Really appreciate the opportunity to speak with all of you today, and I look forward to the Q&A and discussion section here after my talk. And before I dive in, just also wanted to recognize two other folks listed here, Amy Simstad and Gregor Skierman, who really played a big part in the work that I'll be talking about. And of course, there are a number of others not listed here who contributed to the project that I'll be describing from South Dakota. All right, so I just wanted to give you a sense of where I'm going to head here in the next 15 minutes or so. Before I dive into the details of the modeling and scenario planning work from South Dakota, just wanted to introduce you all really briefly to the Climate Adaptation Science Centers, or CASCs, as we call them for short, to give a bit of background and make sure you all are aware of who we are and what we do, in case that's of interest and relevance to your work. Then I'll provide a little bit of background on scenario planning, just for those that are not familiar, and then dig into an actual case study from South Dakota, and then just one slide kind of with some closing thoughts on science and management generally. So the CASC network is comprised of 8 regional centers, and we also have a headquarters office, national CASC located at USGS headquarters. And as you can see here, our mission really is to deliver usable science that can be used to help fish, wildlife, waterland, and people adapt to a changing climate. And within that work, we certainly do consider and try our best to account for other important changes, such as invasives. So here's what we look like in terms of a map and sort of our boundaries, which here follow state lines. We do try to be a bit fuzzy about this and work beyond our sort of specific domains, but this gives you a sense of where we work. And we are the North Central CASC. Zooming in here, essentially we're overlapping quite a lot with the Missouri River Basin boundary, but we have a 7-state region, and we're comprised of both federal staff, such as myself, as well as a university consortium. So we have a host institution at the University of Colorado at Boulder, and we really have sort of a deep bench, not only because of them, but because of the consortium partners at other universities and NGOs in the region that are listed there in the lower right in italics. And our main partners that we seek to serve are state agencies, state fish and game in particular, DOI agencies, and also tribes. And again, we really do have an emphasis on actionable science. We want to produce science that is usable by managers in the decisions and planning processes that they live in. Okay, so one of the tools that we've been using here is scenario planning, and to provide a bit of rationale for this, I like to put up some of the typical graphs that we often see when we talk about future climate changes. Here's some graphics from a particular place in South Dakota that I'll get to later. But as you can tell, there's a lot of uncertainty in terms of what will happen with climate, in terms of mean temperature and mean precipitation. So we know things are going to get warmer. They have been getting warmer, but we don't know how much exactly. In some cases, with things like precipitation, we don't know if it might get wetter or drier in some locations. And from a management perspective, it's hard to know what to do with this kind of information. How might this actually sort of affect your on-the-ground decisions? On the other hand, we recognize that changes are already happening, as you can see from this map of temperature in national park units around the country. They have been warming substantially, and by all accounts, more changes are expected with some possibly dire consequences. And so we're in this situation, or really managers are in this situation where there are things are happening, but there's also a lot of uncertainty with what will continue to happen. And I would add that this is not only uncertainty related to climate change, but of course with invasive species. Having new species coming into areas is a concern in a lot of parks, as we were seeing from Catherine and Terry's talk. But nonetheless, despite this uncertainty, managers still are taking actions. They got to make decisions to try and meet their goals as best they can. And so how can we sort of know what to do in that kind of a situation? And this is an instance where scenario planning is highly appropriate. And I like to kind of remind folks that scenario planning isn't necessarily something very esoteric and abstract. I think it's something we sort of do all the time. It's intuitive. We make decisions under uncertainty a lot about retirement, about investments, selling houses, whether or not to take your umbrella to work. These are all decisions that we make under uncertainty, and we sort of in our minds or implicitly game out what might happen if we make different decisions. But more formally, scenario planning is a flexible framework that's intended to support decision making under uncertainty and uncontrollable conditions. And I think this, what it is, really becomes clear when we contrast it with a forecast-based approach. As you can see in the figure here, forecast planning, you sort of say, well, here's the future we expect, maybe with some range of uncertainty around it. Whereas with scenario planning, we do our best to take into account all of the uncertainties before us and look at a broad range of plausible futures rather than a single future. And I'm a little bit sort of general here in terms of my description of what it is, because it's been applied in a lot of different forms in a lot of different situations. So there have been military applications of scenario planning. It was really popularized in private industry by Royal Dutch Shell to weather variability in things like oil markets. But more recently, natural resources and cultural resource managers have been using it in places like the National Park Service and Fish and Wildlife Service. And so, with this sort of broad application and more knowledge of this tool, there's increasing interest in using scenario planning, particularly for climate adaptation, but also considering other non-climate stressors. But what we've found is that managers often want, or in some cases do indeed need, quantitative information. And I think from the scientific side of things, we also have to recognize that there are some really complex interactions between system components, climate management, that we can't necessarily track through what might be a more qualitative scenario planning exercise. And so that's where our quantitative ecological modeling tools, I think, can really bring some strength, and tools like the ones that we just heard about. And I'm actually going to be speaking today a little bit about another type of ecological modeling tool. It's a bit different from species distribution models, and that is ecological simulation models. And during Q&A and discussion, we could talk a bit more about how those two things relate. But the simulation modeling tools I'll be talking about are really meant to be, or can be used as, virtual laboratories. You might think of them as a virtual system where you could kind of play out different experiments or scenarios without sort of the costly or risky actions that you might need to take if you were to do those things in reality on the ground. All right, so I'm going to briefly talk about some recent work that we did using qualitative scenario planning and quantitative modeling in southwest South Dakota. And the study area is centered on Badlands National Park, but included federal national grasslands as well as some tribal land as well. And I think the key for us in this work was that we really wanted to start with the management issues that folks on the ground are concerned about. You can see sort of the general list of them here. Grasslands, including non-native species like cool season exotic grasses or noxious weeds like Canada thistle, but also infrastructure, paleontological resources, and threatened and endangered species. And so we used these concerns to then say, okay, well, what is it about climate then that we care about? So rather than just saying, well, let's look at average temperature and precipitation, let's look at the actual drivers for those key resources. And in our case, here's the list, things like spring precipitation and heavy precip events, growing season onset, and the like are important for those resources I just showed. And so our challenge then was to look sort of forward with the best available information we have and say, okay, well, what do we expect might happen in the future with these climate drivers? And to do so, we'd look at different combinations of the variables and these kinds of bivariate scatter plots. So here, you can think of the x-axis as the start of spring. When spring starts, negative numbers are earlier, and the y-axis is spring precipitation. If we look at the spread of the model predictions for the future in these variables, we see quite a lot of spread. So spring could come anywhere from a few days earlier to several weeks earlier. And spring precipitation might increase by a few inches or decrease by a few inches. And so what we sought to do is select just a small set, in our case 4, of these global climate models that captured the range of uncertainty in these and those other variables. So we sort of did that selection, and then we needed to summarize this information in a way that's a little less wonky, more accessible than just those scatter plots. And so we summarized info in a variety of forms, tables, bullet points, comparisons to historical events, etc. And we brought this information to a participatory scenario planning workshop. And this is where we could really dig into what these scenarios might mean for folks on the ground. And so we brought in subject matter experts as well as resource managers to really turn to them and say, well, if these futures, these 4 different climate features were to play out, what would that mean for your resources that you care about, and how might you respond? And so sort of generally, and I'll come back to some more specific findings in a bit, but scenario planning, it's really meant to facilitate some open-minded thinking about divergent futures. And this isn't just, again, on climate, but also thinking about non-climate stressors like invasives, and allows us to look at a wide range of resources. And on top of that, it helps us make sure that when we did our quantitative modeling, we were looking at the most important variables and scenarios instead of just sort of doing the modeling in a vacuum. We could use this process to inform the modeling work that I'm just going to talk about briefly here. So we built this state and transition simulation model of vegetation in the region. And really our focus here was on tracking vegetation, biomass, composition, but also costs of taking some various management actions. And what we wanted to do is model the same 4 climate futures that folks considered in the workshop. And then layer on top of those climate futures their management alternatives that they told us were of interest. And this included varying things like grazing rates and season, prescribed fire, the way that invasive species are inventoried and treated, and we could vary these things by different jurisdictions and see what would happen. And so just to give you a few examples of the kinds of things that we could find by doing this kind of quantitative modeling is we were able to identify some trade-offs in management. So folks may be inclined toward a more conservative livestock or bison management approach to, kind of account for those really dry years, make sure there's enough forage available if a drought hits. But one thing that we found, and this was really confirmed through some conversations with managers, is the trade-off there is you may end up with more cool season exotic grass than you might if you had higher stocking rates. And so at least being aware of that, making that decision, if you are going to be more conservative, that might be okay. But if you're doing that, you may end up with more of this cool season grass. And then also, as I indicated before, we can track costs. And so this is reflective of something Greg touched on in his talk, that, having a larger initial investment in eliminating something like Canada thistle could indeed pay off over the long term. But if there's not good cross-jurisdictional coordination, then of course that thistle might just creep back into your management unit, and your large initial investment may not pay off. And then we could also compare options for things like woody encroachment, and there are ways to identify lower cost options for achieving sort of similar results. So really, I think a couple of just sort of general points about this case study. I think we all learned from what I kind of call looking over the fence. We could look at different jurisdictions and the different strategies of those jurisdictions, both currently, but also through the simulation model. We could game those out forward through time. And the qualitative and quantitative approaches, I'd argue, provide some really nice complementary information. And that included, the ability to sort of find some maybe surprising findings or counterintuitive findings. And I think it helped to narrow the range of futures that folks need to plan for, and kind of help get over that paralysis of dealing with the uncertainty of what might happen into the future. And I'll just say that so sure, we had our scientific publications and whatnot, but more recently we've spent some time and effort working with NPS and their communications staff to really boil all this work down into something that is accessible. We put together, I think it's a 4 or 5 page glossy summary of the work. If you Google NPS Scenario Showcase, you'll get to their website, and there's a link to a digital version of this. But you can see here that the colors are different, but we've still got those 4 different climate futures as the columns here, and then just using simple things like direction and size of arrows to communicate what that might mean for different climate variables. And then we summarize in this table here what that might mean for different types of resources and what the management implications are. And so to give a bit of an example, zooming in here on the vegetation resource category, the work, both the qualitative and quantitative work, indicated that sort of continuing the current combination of infrequent fire and conservative bison herd sizes and low levels of weed inventory and treatment, this is not going to allow you to attain your current goals. And so it's a red flag, and we can sort of identify some other things that land managers might do to help achieve their goals. And then lastly, I'll just say as well that we're not only trying to do that translation piece, but really build this scenario planning work directly into planning processes. So here's the Park Service's planning process, the resource stewardship strategies that they're using across their park units around the country. And I would just say that for non-Park Service folks out there, I know that the CASPs are really interested in figuring out, identifying other planning processes, decision processes that other agencies use, and similarly really building the science in to meet the timelines and needs of those planning processes. And so that really gets at my last slide here, that we see it really, there's a couple of important things that we really believe in, and that is linking science to manage decisions and processes, as I just said. And as we do our science, really starting with management concerns, working directly with managers to co-produce the knowledge that's of interest to them. And I think now, or I hope I've convinced you that there are ways we can embrace uncertainty, whether it's in climate or invasives, to make some plans despite uncertainty. So I'll just stop there, and I'll turn it over to Jeff and go from there. Thank you all.
Great. This is really interesting suite of presentations. I think there's a lot of food for thought here. One of the things maybe we'll do is we've got some questions coming in from the webinar, deal with kind of more of the technical clarification questions to get that out there, get out of the way, and then maybe go on to more of a collective conversations across the group. I did see a question related to Catherine's and Terry's work related to were there parameters used to spatially constrain the model, which then can be used to as the parameters within the model, and I would imagine it's sort of those national layers and the observational data you have, but maybe you have additional insight as to anything initially to spatially constrain what you were doing.
Yeah, the development of the models were spatially constrained based on the occurrence data locations, and similar to the polygons that you saw on the website around, that was how we constrained kind of the background data points.
Great.
So yeah, the models were constrained based on the known occurrences that we had to create the models.
Great. And what was, I think the spatial resolution is 250
No, it's 90 meters.
Oh, great. And I think I saw one question on there with your example in Wyoming on the cheatgrass. What was the satellite data that were used?
Landsat imagery and different combinations of dates that related to when cheatgrass is distinct from the native vegetation.
And that was at native Landsat resolution?
Mm-hmm, at 30-meter resolution.
Great. And a technical question, Greg, for you. Someone asked about the ecosystem services. Did that come into your kind of financial or economic assessment that you did in the state of Washington there?
It did to some extent, and it kind of depended on the species. Some of them tend to impact ecosystem services more than others. I mean, we looked at things like effects on wildlife and hunting, fishing, recreation, those kinds of things. But it's kind of hard to put a dollar figure on, the fact that somebody can't go out and enjoy the wilderness because they can't walk through all the yellow star thistle or something like that. But yeah, we did include that as best we could.
Good. Okay, that was, I think it takes care of most of what we had on maybe specific, talk-specific technical questions. There were some comments, and I think it is a good point of conversation as far as data sharing. Someone highlighted that, sharing between counties in a given state might not be as collaborative and coordinated as it is in Washington. That can lead to some problems. Maybe I'll turn it to the presenters. With respect to the data sharing. I think the state of Washington had a really exciting array of options. There was some question. I think citizen science is an interesting component to that. I think EDD Maps allows for citizen science and some phone apps to be used. It doesn't coordinate those activities, within a given region or county or school system, but it does at least give you that tool, and I know it's been used by citizen scientists. But just maybe a question to all three, on that data sharing, kind of at the state level, how those tools that Greg shared with us are used, and what that learning curve was like, how Catherine and Terry, that might be contributing to Park Service observations, what system are they using, how it gets rolled up into Bison. And then for Brian, it's kind of interesting to think about that co-production of knowledge, and kind of I would see the scenario planning as utilizing those data more than collecting it. But let me turn it over to you all to sort of comment on data sharing. It seems to be as perennial as dandelions in my yard. I've been talking about it for 15, 20 years, but I think some of the new tech tools and some of the new tools on mobile devices, cloud sharing. Storage isn't that big of a deal. We can transfer entire libraries. So there's some exciting opportunities. But again, let me ask you guys to share your thoughts on it.
Well, from the state level, it started with kind of us committing to store all the data, house it, put it into a format we can use, and because there was a lot of data out there before, we didn't realize how much, but there was just no place to put it. So we built a data set, and we have a we'll take data in almost any format and massage it if we need to get it into our data set, and then to make it valuable to people to send their data to us. We were able to provide tools like maps and some modeling and those kinds of things as kind of a carrot. But you know, we're open to sharing data with anybody and everybody, and sometimes that can be a real pain because you got to clean up a lot of data, and some data you find out isn't that high quality. So that's it.
And Catherine or Terri, maybe you kind of describe, you did list some of the data sets you're going after, you've grabbed. Maybe there's opportunities with, you know, working at that state level land manager who's maybe tapped in more of those county weed folks, and I don't know how we think about ensuring that those are part of those national systems. I know a lot of work's been done on that, but maybe you could comment on that work or potential future directions on that mobilization of data.
I think
I would defer to Catherine on this question.
I was just going to say, I think most of the federal data sources that we originally had to go to on their own are now incorporated into Bison. And then a lot of the state level data seems to be in EDD maps. So between those two, we were able to get data from a lot of sources.
Yeah.
And related to citizen science data, I know there's some that can get automatically added into EDD maps. With Bison, they have a lot of data from iNaturalist that they take. And I know there is some cleaning related to that they do, or filtering, I should say, that is useful for these applications. So I know one species that we're looking at recently, there were, you know, locations in iNaturalist that were in people's yards where they haven't really spread out into the wild, and so we really wanted to make sure that those were filtered out.
Yeah, I think we've seen examples with the eBird and kind of leading a charge on that quality or metadata capacity to filter. I think EDD Maps does a great job. They do at least a round to make sure, you know, that they do a professional evaluation of contributions. So I think citizen science is becoming more and more viable as an option for that. And I think, you know, maybe I'm making a note is that the National Invasive Species Council, and I know we've had some discussions with Bill at Western Governors and others about that data sharing, is, you know, staying in touch with Greg as far as that state's, you know, and the concerted effort they've made on all that data collection to see if it indeed is getting rolled up. So that may be something we could kind of think about and in the future. And maybe Brian, if you want to comment about kind of that data access and how it feeds into what you're working on.
Yeah, sure. You know, as you kind of indicated, Jeff, you're framing the question. We're, you know, and as I mentioned in the talk, you know, we're really interested in co-producing information with our partners, and so in a scenario planning workshop, that tends to be qualitative. You know, we're sort of eliciting their expert knowledge to help understand environmental responses, and you know, we sort of capture that and share it through some of the examples I gave you. And then as far as the quantitative modeling tools go, yeah, I mean, being able to pull in things like invasive species locations and even empirical relationships between invasives and climate is really important for making the models work, making them work well. And in terms of model output, I mean, we're committed to sharing that, particularly the federal agency. I mean, making the data publicly available is part of our mandate. But I did want to touch on one point that I think is another opportunity to, say, work with or sort of learn from folks like Greg is, you know, I was really interested in where Greg showed his map of the invasive species locations, but if you zoom in, the locations are fuzzed, so that a private landowner, you know, they're not put out there in terms of a privacy issue, and that relates really closely to our work with tribes, and you know, tribes have they're sovereign nations, and so their information they may or may not want to share. They may want to share it with us as scientists to help to do some analysis, but then in terms of output, they may not want to share things, just as a private landholder may not want to share things like the location of invasives or other species. And so I think we could learn something from Greg and his work to sort of fuzz those data locations so that they are shared publicly, but not to the level of detail where there might be privacy concerns.
And that, I think one question or topic I'd like to touch on is that private, state, federal issue. I think that you see folks focusing on where their mandate and mission take them, and that makes a lot of sense. But I think that one of the opportunities that the Western Governors Association brings through these webinars and through some future work is utilizing or leveraging off of the work that's being done in those various jurisdictions. Maybe you all three could comment about kind of how that private, state, federal collaboration might unfold, what you've seen already in your work, or where it might go from here. Maybe we'll start with Greg if you have comments on what you've heard and saw today, and then we'll go to the NPS or USGS perspective.
Yeah, we do collect points on private lands, and we work with tribes, and a lot of that work is done at the county level, and they build those relationships with the landowners so that they trust each other. And part of that trust was that we not make the data available, to the public, other than generally like we do in our distribution map. And our state weed law does provide, with a warrant, we can go on anybody's property and look for weeds, but we tend not to do that. But if we have to, we can. But in general, it's just like you were kind of saying, building trust and not taking advantage of that kind of information. So.
Great, and then maybe we'll turn to USGS and NPS, but I'll put Bill Whitaker on notice. It'd be interesting to see if he wants to chime in with respect to the Western Governors Association role and thinking about that going forward in that collaboration between these kind of multi-jurisdiction or currently jurisdictional efforts and how they could feed into other jurisdictions. But maybe, I don't know, Brian, Catherine, or Terri have any comments on that Fed, state, private collaboration.
Yeah, this is Brian. Oh, go ahead, Terri.
Oh, thanks, Brian. We have 17 exotic plant management teams across the country, and they do work very closely with adjacent landowners and are able, through agreements, to actually assist private landowners with treatment. And in the West, of course, we work closely with the cooperative weed management areas and the states on projects that impact all of us. And we have one team, the Lake Mead team, that really works on a watershed scale and works with the county and the city of Las Vegas and works with the tribes and other agencies in the state as well. So we are definitely working as very collaboratively across the country through the exotic plant management teams on issues that impact all of us.
Yeah, thanks, Terri. I'll just, I guess I'll say that, on the one hand, as I mentioned in my slides, we're very interested in tying our science to specific decision or planning processes, and so I think there's a bit of a tension there in the sense that that might sort of shoehorn us into a specific agency, right? Like if we're working on developing a resource stewardship strategy with National Park Service, we're going to focus on their needs for that planning process. On the other hand, in working with Badlands in the case study I showed, we were pulling in, at least in that case, we didn't have state or private partners, but I could imagine similar benefits to where we pulled in Park Service, but also USDA folks from the National Grassland, and that was an instance where by having those people in the room together, they sort of were able to talk about and I think learn from one another's experiences even in a fairly short time. So we were, I mentioned that trade-off between sort of, stocking rates and cool season exotic grasses, and I remember hearing some conversations in the room between the National Grassland and the National Park where they were saying, oh, well, wait, in the grassland you guys don't have that same issue with these cool season exotics, or not to the same degree we do here in the park. And I was like, oh yeah, we don't. And I think they started to then tease apart, oh, well, maybe it's because we're stocking, quote unquote stocking. at different densities, have either different densities of bison or different stocking rates for cattle that might then relate to that cool season exotic. So a clear management kind of connection there that they were able to make by just being in the same room together. So good benefit from working across jurisdictions.
Great. I don't know, Bill, if you want to add anything or any comments from WGA. We've got a few more questions and only about 5 minutes. So I want to get to those.
Sure. Thank you, Jeff. Yeah, that is WGA's bread and butter, is looking at state-federal relationship, interagency collaboration, and just looking at what's working and how it could work better. So, the work we do on invasive species is no different. The conversation about data has been really interesting. Those of you who follow what WGA does, I think we've done a lot of work on invasive species data. We identified that as a priority in our previous policy resolution, which came out nearly 3 years ago. And over the last year, last 3 years, we've had a lot of really good work done on that. We had, in March of last year, 2017, we had a workshop, 2018, excuse me, a workshop in Denver on invasive species data management, and we got a lot of the folks who work, a lot of interagency folks and the folks who work on invasive species data issues together to talk about how to improve in data management in the West. And I think there were some findings and recommendations that came out of that I think really did help offer some guidance and to how state and federal agencies and nonprofits can communicate better on data. And that's not all the work we're doing on data. I think I would look for what we're doing, some of the outcomes of the report. I'm anticipating one of our big identified priorities has been for a long time is Western Governor's intention to lead a campaign in the future really highlighting what the importance of invasive species data and the importance of invasive species data sharing. So there'll be more information about that in our report from the initiative that comes out in June. And as far as just general collaboration and coordination, yes, that is something. If there were one theme from this whole initiative, I think that one of the emphasis is that there needs to be more to look at invasive species management as a landscape level issue and not just sort of a regional or parochial issue. And that is what we're striving to do. And I can't speak to a lot of that stuff now, but I think there's going to be a lot of really interesting work coming out of this initiative. We're not going to stop in June. There's going to be a lot of really interesting work and efforts to help sort of work on and improve that collaboration. So just a teaser there for the report.
Great. We'll all be watching closely for that and reading it carefully when it comes out. We only have a few more minutes. With respect to, I thought it was interesting to see last week's talk on the state-federal partnerships and the quarantine issues, and then Catherine's example where quarantine areas were shown. So possibly one suggestion for Inhabit is to look at those quarantine areas and have those overlaid in it. And another question that we could probably handle in short order came from the audience or the participants was, what's the time window for providing that input? Maybe Terri and Catherine could answer that.
There's not really a timeline for it. We're continually doing development, and we have obtained funding for a second year of development, and so we welcome feedback at any point in time when people are able to. And I wanted to also quickly say that currently the website is hosted on our developers' Shiny account, and it will be transitioning to USGS server soon, which should help with some of the access issues that people have been having.
Okay. Great, and I think the slides are going to be available through WGA and recording of this. Maybe one more question that came from the audience related to Brian's work. Was there any surprises in like an NPR interview? We're almost out of time, so 30 seconds or less. Give me, what was the big surprise, and then we'll kind of leave it to Bill and or Kevin to close us out.
All right, pressure's on. So I think a couple surprises, two that I'll mention. First was sort of the number of bison that the park might be able to sustain, at least according to the simulation modeling work. We're doing some additional work to confirm this, but from the initial work, it appeared that they may be able to indeed sustain more than initially thought, even considering really dry years. And then that trade-off that I mentioned was the other surprise, at least for me. And it was sort of one of these things where, on the one hand, it was a surprise. We didn't expect this trade-off between the population size of grazers like bison and those cool season exotic grasses. But when we turned that back to the managers and said, hey, well, this is kind of what the simulation model seems to indicate, is that does that make sense to you? Does that jive with what you're thinking? And they, said, yeah, well, it does, especially when we looked across those jurisdictions, as I mentioned before, comparing the grassland and the national park and their different stocking rates and how that related to the amounts of the invasive species. So some surprises, but ones that weren't totally outlandish, and I think were consistent with management thinking.
Right. Yeah, I think we've seen, there's probably a lot of stories we could tell about how these have been worked. I think for boots on the ground, Terri really is working with those people day to day. I'm sure Greg is as well, and what we saw. So there's a question on that. But I think in the interest of time, I want to thank everybody for a really insightful presentation, a lot of great material that's going to proceed and continue. And with that, hand it over to Bill if you want to close us out and any concluding remarks or logistics before we sign off.
Thank you, Jeff. I will just keep my closing remarks very brief in that thank you, everyone, for joining, both the participants and the audience. Jeff, I think you did a great job moderating. We appreciate having you. And Greg, Catherine, Terri, and Brian, thanks a lot. Those were really interesting conversations. I think that was a really good deep dive into an important issue. Data and information are really a foundation to good invasive species management. It's impossible without it, and so it's really important to focus on that and try to streamline and refine those processes. And I think today's conversation highlighted the good work you're doing towards that end. So I really appreciate you taking the time to share that with us. And I just want to highlight again, let everyone know that this will be posted along with all our other webinars at the WGA website, westgov.org. So I encourage you to check that out. And then next week, next Tuesday on May 7th, we're going to be releasing a pre-recorded webinar on innovative approaches to addressing forest health and invasive species in the Pacific Islands. Really good conversation with Pacific Island foresters and Forest Service folks, U.S. Forest Service folks. Great conversation. I encourage you to watch that as well. And then that will be the final webinars in this series, at least for the initiative. And then there'll be there may be some ones here and there to address specific issues in the future. But the next big item after next week's webinar is the report. And I really encourage you to take a look for a new report, look for the new policy resolution, and then look for all the work that's going to come out of it. It's Western Governor's work on this issue is not going to stop in June. It's really only getting started out of this report. So look for that, and please join us in our efforts there. So with that, we will sign off, and thank you all for a great webinar.